Hey guys, this is Miss Jags. First of all, sorry I'm not here today. Was summoned for jury duty, so I'm serving my county and my community by doing that. So hopefully I'll see you tomorrow, and we can just carry on. But today we're going to continue with our next unit. The next day that I'm in class, I'll give you back your assessments, and we can look over them. Some of you did super great, and I'm really proud of you. Some of you know your material and that didn't reflect very well on your test. So we'll review that and kind of see what we can do to help you improve your score. Your sub should have given you 3 separate papers. The first one is our new title page. We're going to fill that out in just a second. You should also have this Unit 2A snapshot. We are splitting up Unit 2 into 2 parts. The first part X is exponent laws, which are going to start today. And the second part is scientific notation, which will start probably sometime next week. But I wanted you to have this so you can see. I know I haven't been doing a super awesome job at reverting back to these things, but you should definitely be looking at that. And then the third thing is our exponent laws today. If we happen to have time, we'll move on to section 2, but we're going to start off with section 1. So if you can find all of these things real quick, that would be super helpful. We're going to start with our unit title page. Now, your guest teacher can pause this video as many times as you need to, give you as much time as you need to glue these things down. But we're going to start with it's Unit 2. Unit 2, and it is exponent laws and scientific notation. Oops, that's not a T. Exponent laws and scientific notation. I don't know what page we're on right now. I don't think I glued in some of the other stuff, so you'll have to fill in the page number that matches your notebook. It should just be the next available page. So the first thing we're going to put in there is our Unit 2A snapshot. And then the second thing we are going to put in is product of power law. I'll zoom in a little bit so you can see that a little bit better. So exponent laws and scientific notation is the name of our title. And we're going to put in the Unit 2A snapshot and the product of powers law. Feel free to pause this and glue those things into your notebook. All right. Hopefully you've all had time to glue that in. I just want to talk through this really fast. This is your unit snapshot. I started giving these to you so that you guys can kind of self-regulate what you can do, what you cannot do, and to see if you successfully are learning the content that you need to be learning. So I have the state mandated standard that we're trying to address, and it says that students should be able to know and apply the properties of integer exponents to generate equivalent numerical expressions. And it gives you a little example. So for example, you should know that 3 squared times 3 to the negative 5th equals 3 to the negative 3rd, or 1 over 3 to the 3rd, which then would translate to 1 over 27. We won't get that far today, but we're going to work our way towards that. Some good need-to-know vocabulary we are going to hit on today, just really quickly. Integer exponents, the word base and power are both important. These words you should know already: squared and cubed. Scientific notation is one we'll get to when we talk about the second part of our unit. Standard notation is just normal numerical numbers. Quantity is the number, and power of 10. These are things that we're going to be working on over this next week and into the next week after. Your targets are here. They're pretty simple. I can evaluate expressions with exponents. So you should, by the end of this week, be able to evaluate expressions with exponents. I can use the product properties of exponents to simplify expressions. Product properties are when you're multiplying things. So when you're multiplying things with numbers, we're going to start our first product property today. And then quotient property. Quotient means division. So we're going to look at those later on in the week. So once you've glued that in, we can go ahead and move on to our product of powers page. I'm going to just take some super quick notes for you just so that we're starting off on the same page. First of all, I know that you guys have seen this before. You have a number and it's raised to a power. This large number at the bottom is called a base. It's called a base. It's the base number. This little number, the superscript, is when you call it a little number at the top. It's a subscript if it's at the bottom, just FYI. But this little number at the top is the power. Or we also call it the exponent. This particular expression means that you have 2 multiplied by itself this many times. So in this case, we have 2 times 2. I'm pretty confident that you guys know that because we spent a lot of time talking about squares and square roots and cubes and cube roots. So just really quick, even if it's an unknown number, like let's say I have a letter A and I put a little number up here. This still means that this is the base and this is the exponent. And as it's written out, you have this letter or this thing times itself that many times. So A times A times A. It does not mean A times 3. It does not mean that. It means A multiplied by itself this many times. So go ahead and look at your original paper, the note that we're going to do today. We're going to look at how to kind of evaluate these exponents if we're multiplying 2 things together. And I'm going to show you expanded form first. We know that 2 squared, or 2 to the second power, means 2 times 2. We know that. We know that to be true. We also know that 2 to the 6th power means 2 times itself 6 times. 1, 2, 3, 4, 5, 6. 2 times 2, 6 times. Looking at this sign right here, that's multiplication. So I'm going to add that little multiplication symbol in there. The parentheses are only here to help us group to make sure that we've done exactly what we needed to do. Now I can look at this whole expression and see that it's just 2's multiplied to each other. And I have 1, 2, 3, 4, 5, 6, 7, 8 2's. So my simplified form is going to be 2 to the 8th power. Next up, I have 7 to the 3rd times 7 to the 5th. Well, I know the first one is 7 times itself 3 times. And 7 to the 5th means 7 times itself 5 times. Looking at all of this expression, I know I only have multiplication. So it's simple. I can just count up how many 7's. 1, 2, 3, 4, 5, 6, 7, 8. And know that this simplified form of that is 7 to the 8th power. Next up, I have -4. -4 to the 3rd power times -4 to the 4th power. So first, I have -4 times itself 3 times. I'm going to turn this autofocus on. Then I have -4 times itself 4 times. I know that this is all just multiplication, so I'm going to count up the things that are alike. 1, 2, 3, 4, 5, 6, 7. So this must be -4 to the 7th power. Now we're at these letters. These letters go the same way as the numbers did. So I know I have x squared. That must mean x times itself twice, 2 x's. And this x to the 5th means x times itself 5 times. And then all together, if I count them up, 1, 2, 3, 4, 5, 6, 7, I have x to the 7th power. The next question is a little bit trickier. I have 2x to the 3rd. Now, it's important to understand that 3, this little 3, is only attached to the x. It is not attached to anything else. So that means I have 2 times x times itself 3 times. This is 2x to the 3rd. 1, 2, and then 3 x's multiplied by each other. Then on the other side, I have x to the 7th. So that means x times itself 7 times. I think that's 7. 1, 2, 4, 5, 6. Yeah. 7. All right. So now I got to count up like terms. I'm going to group them by things that are similar. I only have this 1, 2. I should have mentioned earlier, but anytime you have a number that's all by itself, it's always assumed that there is a 1 right there. It's always assumed that there's a 1 right there. Then you'll never actually write a superscript that's a 1, but it's assumed that it's there. So this 2 is all by itself, so it's just 2. Now I count up my x's just like I did before. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 2x to the 10th. This next one seems a little bit trickier. I have r squared. That's r times itself. Then I have 3r to the 4th. That 3, because it's not in parentheses together with anything, is all by itself. It just means 3 times r to the 4th. So 3 by itself, and then there are 4 r's. 1, 2, 3, 4. And then I have a third thing right here. It's just an r. So multiplied by r. I do just like I did previously. I look and collect the things that are similar. I have 1, 3, so I'm going to pull that out. And then I have 1, 2, 3, 4, 5, 6, 7 r's. So I have 3r to the 7th. Finally, last example before we start talking about what all this means and some shortcuts. We have y to the 5th times y to the 7th. Y to the 5th is y times itself 5 times. And then y to the 7th is y times itself 7 times. Now I just got to count up how many y's. They're all the same letter, so I just got to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this simplified should be 11, or should be y to the 12. Don't know where 11 came from. All right, so I'm hoping by now you've seen some patterns, or one pretty obvious pattern. So when we were doing all of this, we ended up counting out how many individual pieces there were. But if you were to create a rule for how to find the product of Power's law, you would probably say that if you have the same base, and remember, the big number is your base, and the little number is your exponent. So if you have the same base, like here I had x squared and x to the 5th, I have the same base, then add the exponents. So going back to some of these examples, 2 to the 2 squared times 2 to the 6th power ended up being the same as 2 to the 2 plus 6th power, or 2 to the 8th power. The same thing happened here. I have the same base, so if I add the exponents, 3 and 5, I ended up with 7 to the 8th. Same thing here. I have the same base, -4. I add my powers together, 3 and 4, ended up being -4 to the 7th. So all of these fit the same bill, even like these really complicated ones. Like this, my 3 was all by itself, so I ended up with 3. And then if I add all of the exponents with all of the r's, I have 2 plus 4 plus 1, that's 7. So I have 3 to the 7th, or 3r to the 7th power. All of this works. Next, it says write your rule algebraically. That means give an algebraic expression using letters that you can kind of plug into. So here it is. X to the m power times x to the n power, we're using letters here, equals x to the m plus n power. And for this to work, you keep the base the same. The base is the larger number, remember? And then you add exponents. Now you're going to practice alone. I'm going to give you just a few minutes to look at these next 4 questions. And when you're finished, I'll show you my answers, then you can kind of compare. After that, depending on what time it is, we'll either move on to Rule 2, or we'll start practicing with our worksheet homework problem for Rule 1. The first side of your worksheet is due for homework, just so you hear me say that and not sub and not believe them. I need to know that you can do this, and I wasn't here today to see what you can and cannot do. So the first page of the homework will be due today. I'll show you that in just a second. But I'm going to pause my part of the video just so that I can finish working these out right here so you can see my answers. All right, coming back to you. Hopefully you paused and had a chance to work. Here is what I ended up with. I'll move that mouse out of the way. One thing I didn't talk to you about in your examples is when you have 2 random numbers. Like let's look at the second example, 3x to the 7th, 5x to the 4th. These 2 numbers, 3 and 15, or 3 and 5, are just everyday numbers. So when you have just normal everyday numbers, they're all still being multiplied together. So you just multiply those 2 numbers. 3 and 5 make 15 if you multiply them together. So I did that. 3 and 5 are 15 if you multiply them together, and then you add in the x's. So I ended up with 3 times 5 is 15, and then 7 plus 4 equals 11 x's. And you can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, I know some of you are going to probably try to squeeze in that just doing the math, the adding the exponents. But for right now, until I tell you otherwise, I really need you to show me the expanded form of these, so that I can know that you know what you're doing, and so that it's kind of guaranteed that you get the question right, at least until we get these powers or these laws kind of under our belt. This is the homework assignment that you're going to be doing. Way back up, there's the full sheet. You're going to do the side that says powers of products. There are 14 questions, and I do expect you to do them all. So whatever remaining time in class you have, you'll be working on that. Have a good day. I miss you guys.